Hey everybody, it's ET. It's 4/10/2020, 6:52 p.m. and we're going to continue on with our Unity project. So I'm going to go ahead and start presenting and let's get started. Alright, so here we go. Tile map creator. Alright, so last time we refactored our grid so that everything's under tile, like everything in tile grids goes here, and all the cells are here. But I could just double click on any of this and we'll see the cell data, which is like kind of the root of all of this. So like the cell exists as a render thing and part of the layer. So this is the actual data. And when I paint it, you see that the sprite changes. Okay, great. So now we have different kinds of layers. Let's make sure they work. So the different kind of layers, yeah, that seems to be working. Yeah. And if I move layer 2 above and start painting on it, I can do that. I can disable it. Alright, it's working as intended, which is good news. Okay, so one of our missions today is to actually make a third kind of layer, and that third layer is going to be a Perlin noise layer. So in order to do that, I'm just going to go here to our different types, and let's open up some code. Alright, so we're going to make a new type of layer, and we're going to call this Perlin noise layer. Okay, go ahead and move that to a new class. I'm actually not sure what we have available. So it looks like we actually have a built-in Perlin noise function. Which returns a float. Interesting. Just to satiate my curiosity, every time I enable this, I'm going to see what the value is. Let's just do math f dot Perlin noise at 0, 0. Just curious. I guess I'm gonna have to do a few things besides this. Our actual, what is it, layer? Let's go ahead and add a Perlin noise layer. Perlin noise layer. How are you getting created? Here. Okay. We'll just create you as well. Perlin noise layer. Perlin noise layer. That's the layer, that's the grid. That's the class. Okay. Seed's gonna start off at 0. So I'm gonna go ahead and maximize this on play. Oh, I don't think I added the option. Let's do a few more things. I'm gonna have to add the actual text, I guess. Oh, I see. Let's say this is the Perlin noise selection, layer selection. That's going to be number 2. I don't know why I'm doing that. So I'm saying I don't know. I don't know why I'm doing any of that. Okay. So I'm going to say if the drop down value change dot value equals Perlin noise layer selection, we'll say layer dot active equals layer dot Perlin noise layer, right? And I'll think about all of that. What are you doing? Oh, you hide the, I see. Okay. If you set it to paint layer, you change that to false. I'll just put that here. What are you doing? I'm gonna go ahead and, yep, set that to true. I'm not sure exactly. Alright, I feel like I am doing this. Okay, I don't mind doing all of that. Switch to random layer, layer dot active. Okay. Sure, I'll even do this here. And then finally, we can switch to a Perlin noise layer. If I do that. This could be very similar to the random. Yeah, I'll get the seed. This should be a Perlin noise layer. Okay, I guess you want this random noise and Perlin noise. There we go. Okay. I guess finally I should probably hard code this next choice. Okay. Uh, we'll see. Hey, got some errors. Um, let's see. First things first. All right. Maybe not first thing first. Let's just see where it crashed. Okay, so you don't have a grid is what I'm understanding. So if I go here, oh yeah, I'm not changing the Perlin noise. Okay, let's try that again. Let's not maybe not maximize on play. Is it going? Oh yeah, there we go. Perlin noise layer. Alright, so it just randomly generated it as expected. But I wanted to see if my random layer, which I guess is, well, I can just click on any of these and double click it. Alright, so our active layer is the Perlin noise layer. Our seed is 0. Our value is 0. I wonder, oh wait, but I'm doing this on the, yeah, this is not ever gonna run. Maybe on awake. Here's layer 1. Let's switch that over to Perlin noise. Maybe it's not even calling it there. I guess instead of here, would I create it? Let's try it out. Or better yet, right here when we actually set Perlin noise. Let me see if I can do it here. I'm gonna just say layer.value equals mathf.Perlin noise 0, 0. Do you have 1D Perlin noise too, or is it just 2D? Might just be 2D. Okay, I was just checking. That's layer 1. Oh yeah, there we go. 0.465. If I do this again, will it still be 0.465? So if I switch it over to Perlin noise, 0.465, and I guess it's because the seed. So if I do 1 and switch this around, what I'm curious about is, I see it's the same value, but I'm wondering if it's because of that seed. But even if I change the seed, it doesn't seem to be changing it. Let's take a quick look at Unity Perlin noise seed. Yeah, I guess you could just inject it. Everyone's just suggesting to just add the seed. Okay, well, we could totally do that. So in order to do that, we just say layer.seed. This is just for one single value in the Perlin noise. So I can, oops, I was compiling. So if I hit Perlin noise, go to that, 0.465, change you to 2, maybe just regenerate you. Did I not regenerate you? I'm gonna try to not do any of that. Alright, so layer.seed. Oh, I'm doing, what am I doing? Cell.seed? No, I'm doing layer.seed, right? I'm getting that Perlin noise layer. I don't know. We'll figure it out. We'll figure this out. Alright, Perlin noise. Let's see what we got. Layer 1 right now is a paint layer. Let's change you over to Perlin noise layer. So at seed 0, you're 0.465, which is the same thing it's been. I changed the seed to 1. I can see the random seed here is 1, but the value has not changed. It looks like it's always that. So as long as you're an integer, I guess the seed will, it just repeats, I guess, after 1. So let me go ahead and just times this by like 1, 2, 3, 4, 5. Which is a shame, I guess. I thought it was always different, even after, you reach 1 unit. Or maybe it wraps around. Alright, so switch you over to Perlin noise. You're 0.465. Let's make you like 5. Go back to the paint layer and then back to Perlin noise. You're 5. 465. So it's always giving me the same value. What am I doing wrong here? I might just want to try it on a simple. Alright, I'm gonna make a quick nonsense script just to try this Perlin noise. Let's call this the Perlin test. It's gonna be super simple. We'll have public input, public float input, public float output. And output equals mathf dot, let's make this a vector 2. Perlin noise input.x input.y, and that should be it. Perlin test. Let's just play that. Right, so that's the same value. That's the same value. So it looks like at every integer interval we're getting the same thing. But if we change it a little bit, yeah, like it's moving. I'm not sure that I understand. Alright, I'm checking out the code. I'm ready. I'm ready just to try this example script, and we'll check it out. What do you need? You need a texture. Okay. Actually, just grab the insides of this script. Yeah. Okay. So our test kind of is not great. What kind of render do we want? Like a sprite renderer? Is that what we want? Maybe it wants to do this on a... Maybe it wants to do this on a quad. I'll go ahead and put a directional light in here too. Okay. I'm just gonna make a quick square box here. So okay, I'm gonna just make a straight up 1080 by 1080. We'll say white square, so like that. I'm gonna just export as on my desktop. I should have the tile map creator, the assets. I'll just put it here. Big white square. And look, in the images, we have this big white square. I'm just put this straight on the quad or there. Maybe the Perlin test goes better there. Invalid width height apply. Okay. Why don't you just become public, just so I can see what in the world is happening? Okay. I can see I'm not getting a texture 2D, which I guess maybe, okay, so it's not there. If I put you on the quad, and then I say, what do I say? Okay, what if I do big white square instead of a sprite? I make you a default, and then I try to put you on the quad, and now I have a big white square. Okay. Kind of getting the same problems. It's not getting the noise texture. Oh, you just want me to type that in here. It's making a texture on the fly. Oh, I see. I got it. And look, we can just do this on enable. That way, we can keep making new ones. Oh my god, why is that so slow? Alright, so if I do scale 5, scale 1, I see. Okay, and here, if I zoom in a little, what do we see here? It's like the same, oops. Oh, come on. What's happened? My Unity froze up. I think it's because I tried to drag that. Oh no, okay, I broke it somehow. I'll go ahead and force close it. Alright, bye Unity. Okay, so the Perlin noise does work. It's kind of weird to set the seed, but we could theoretically set the seed if we wanted to. And to do that, we could just, like if I had this quad, maybe a light, and then put the Perlin test on here. Make it like 128 by 128. And change the scale to like 6, 8, 10. Uh-oh, it's already freezing on me. Why is it freezing on me? Let me just look at the code. Noise texture height, noise texture width. Yeah, I guess it's doing a lot of this. And I guess if I change the scale, yeah, I don't know. I'm gonna close Rider too. Maybe that's causing some issues. But this is all frozen up. Can't do anything back here. So, okay, the Perlin noise function works. The seed thing, we might have to look into later. But it's also freezing up my system, which I'm not very excited about. So I'm trying to figure out how I can incorporate this into my project without it freezing it up. Alright, so here's my project. And we're drawing on the layer underneath, drawing on a different layer, hiding layers, showing layers. Okay, if I do layer 1 and decide to change that as a random noise layer, now we got random noise. And wait, why am I on layer 3? Okay, so with the Perlin noise, what do we want to do? I think in order for me to understand it, and I guess whoever's going to be using this to understand it, I should just implement the Perlin noise function myself. Yeah. Because, yeah. It's just important to know. So I'm just gonna look at other people's code right quick on GitHub. And I see there's a 1D, 2D, 3D Perlin noise project. That's great. This is the paper, the important paper. And here's the test. Oh, is this Perlin? Is this the actual usage of it? Oh no, it's the actual noise function. Okay. Let's take a look at this. Let's make it big. So we have the Perlin noise. We are just getting an integer of whatever we're typing in here. Looks like we're only getting a byte of that. So, okay. And then we're getting the floor. All right, I'm just seeing if I understand this. We're getting the integer portion of the x here, and then that's just going to be a byte. It looks like here we are getting the decimal portion, and then we're fading on the decimal portion, and we're lerping between. Oh, I gotta see what we're doing. That's a function I don't know, and fade is a function I don't know. Okay, so that's fine. Let's take a look at fade. Alright, so fade is this function. Looks like t to the 3 or 4 or 5. So that's a function. I think that's the function that's in this paper. It's probably this guy right here. Hey Joe. Right, so I'm trying to like, this is like the most basic noise over like random noise, right? And so Perlin noise has a relationship between like what came before and what came after. Whereas like if you ran random.noise over and over again, you'd just have like random points in space, right? Where Perlin noise has this function where it kind of smooths that all out. So, yeah, that's the benefit over like just random noise. Now, what's the benefit of this over other noises? I mean, it's not really any benefits. It's just it's how you want to use it, right? Like this might be a certain tool for a texture or a map generation. Yeah, it's like a gradient noise function, right? And I'm just trying to figure out like exactly how it's supposed to work. So, okay. That's the function. It's kind of I think I have a video here. This is the fade function of that Perlin noise from that paper. And it basically does something like that when you go between 0 and 1. So, great. So it's not just a linear ramp. That's the kind of like, if this was like 0, 1, 2, 3, 4, that ramping makes it so that it doesn't seem so blocky at the actual integer intervals. Like it actually is smoothly transitioning to the next one and to the next one. So that's why it has that like kind of ramping function. Right. So where was I? Alright, so that was the fade function, and that's just straight from the paper. And you're just doing that over the decimal portion of the float. And so now we're lerping, and what's this actually mean? I don't know. I mean, I know what lerping is, but they have their own lerp that they wrote right here, and it's, was it 4 parameters? 1, 2, 3, 4. Oh, and they have this gradual, which is probably the gradient. Oh yeah, gradient. Okay. And so what that's doing is grabbing an x, the actual integer x, and the decimal portion. Alright, so before we even look at the lerp, let's look at that. Alright, so grad, and that. Okay. Ah, so it's just a hash. Okay. So like if the first bit is set, or isn't set, get the positive of x or the negative of x. And what we're passing as the second part of the grad is, oh gosh, I hate going up and down. At least through the website. So, okay. That's so strange. It just goes like positive, negative, positive, negative, positive, negative. And then this part is going to be the decimal portion. Okay. And we're just returning the positive or negative of that decimal portion. Okay. No problem, no problem. And then we get the next one, plus 1, which is just going to be the negative of this guy. And then this is going to be, I guess you can almost think of this as the inverse. Okay, so if this is negative, this is going to be like a negative, but like the other portion. So if it's like 0.6 here, this would be like 0.4. And they'll be of the same sign, if I'm correct. Because this is negative of that. Okay. So that's the 1D gradient. That's it? I feel like I'm missing something. Okay, well. Man, I really need to just like write this down. So we have, right, we have the gradient, decimal portion, and now we're lerping between these three things. Alright, so what's the lerp do? So, yeah, it's basically the straight up lerp function. The starting point plus the change in that times t. Right. Easy. Okay. Then we times this by 2. Why? Oh, okay. Before we even do that, we're going from the faded x, right? To the actual the gradient, right? Okay, so to me this just sounds like we're getting 2 points and we're gonna decide where in between those 2 points we are, and then basically using the fade function and the lerp function we know exactly where we are. The times 2 thing is throwing me off a little bit, but I get it. I get this. Alright, I want to just recreate this and just draw a line and see what we can get with this. So I probably should do this outside of this scene, just so I can have a nice fresh scene to work with. Let's just go ahead and make like a quad we can draw on. Alright, so we have the quad with the light on it, and I'm just going to move this out of the way. Just do that globally. Yeah. Okay. So we're gonna draw on this guy, and let's just kind of work off of this Perlin testing that I was working on earlier. We'll go ahead and add the Perlin test right here. Perlin test. And we'll just make this like a 200 by 200. Okay, where's my code? Okay, I'm gonna go ahead and delete. I don't need to delete any variables. All right, so we're getting the renderer. We're making a new noise texture. Yeah, we're making a new array of colors. That's great. Cool. This is where I'm gonna actually work on, is this calc noise thing. Right now I just want to draw, let's just say I want to draw a line from like the middle of the square. So really that's just gonna be, I just want to make sure I can just use very simple drawing functions in here. So we have pix height, so if I grab var midpoint equal pix height divided by 2, that should be like the midpoint on the y, so midpoint y, and then we can just go for I equals 0, I less than pix width, I plus plus. We should be able to color that in. So this is not a 2D array, this is a 1D array. So just gotta think about how it goes across. So if we want x to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this to start like at 10, 11, 12, 13, that will be that will basically be color pix I plus midpoint y times pix width. And that will just, let's just make that a black color and let's see what happens. Okay, I'm gonna just see what happens there. Great, nothing happened. Alright, let's see. Do I have to set the rest of them? Alright, so I'm gonna just set everything to white. Maybe I'll just do that first. Or maybe I'll set everything to red just so I can definitely make sure we're doing that. So that one I'll just do a for each. Var color in pix color dot. Is that what I want to do? It's not what I want to do at all. It's not what I want to do at all. Let's just do another iteration like this. I less than pix dot length I plus plus. And then we can just say pix I equals white, red. We wanted to make it red. Okay, let's see what that does. Even this is not red, so I'm doing something wrong. Yeah, Joe, I'll see you in a little while. I'll be there. Oh, I see what I'm not doing. I'm not applying the texture again. That's what's happening. I bet they do that here. Oh, yeah, they're doing some extra functions here. So that's what I'm not doing. Alright, here we go. We got it. We got it. There we go. And we got our white line that goes across. Cool. Alright, so we're drawing a line. That's good. Alright, I'm going to make that black just because. Okay, so I just wanted to draw this 1D noise function, and that's gonna go. Um, yeah. So if we wanted to just to do like a math.random, we could just do mathf.rand. No, how do we do this? Random. Let's do it Unity engine. Oh, random.range is what I gotta do. And so that should just give us a random like bunch of dots everywhere. Okay. So that's randomly generated noise. If I did like Perlin, maybe that would be helpful. So let's just use like that I, which is really should be X, I guess. And then I'll just say 0. Oh, what did I mess up? Oh yeah, because you are a float. That just went straight to the bottom. I wonder why. Or is that? Oh, I'm gonna have to map this. Let's make a quick map function if I don't have it yet. Wait, I do have math. Math.map? No. Let's just make a map. Float map. Private void float map. Let's just say float value, float old min, float old max, float new min, float new max. Old range equals old max minus old min. Value normalized equals value over old range. Var new range equals new max minus new min. And return normalized times new range plus new min. Alright, so that should be a map function, and that should return a float. And hopefully we can just say map this guy from 0 to 1 to 0 to 200. Let's see what that looks like. Might be doing something wrong too. We got the range. We got the, oh, maybe the value minus old min. Go ahead and yeah, that should be fine. Might be from -1 to 1 too. Oh, you know what I'm doing? I'm getting at every, this Perlin noise thing doesn't like, uh, what am I trying to say? This Perlin noise thing is the same at every interval, at least this function. There we go. Okay, and you might be from 0 to 1. That's just like a cosine, right? Or a sine. Um, I'm just thinking, sorry, I know. Doesn't lead to great streaming, but this helps me do what I need to do. So that is a straight up the Perlin noise in Unity. I wonder what would happen if I just switched these. Yeah, I don't know. Alright. Let's try to make our own Perlin noise right up in here. So we're gonna make a float. We'll just call this Perlin noise. I've done this in another project, and maybe I'll pull that up now, just cause I might need to. Did do some copying of code though in my other project too, so not too proud, but we'll see. We'll see what we got. Okay, so in here I have maybe this Perlin noise. I see I also have a map function like the other one. I'm still not sure about this gradient thing. But let's go ahead and yeah, I see I tried to break it down here. Let's not worry about the frequency just yet. Alright, so we're getting the int part, that's great. Then we're getting the float part. And that's cool. And then we're getting the inverse. And that fade function is really the thing from the paper. It's this guy, 6T. Three, 4, 5, 6. Is that 6 T's? 2. Although that's not right. That's just 6 times T, right? Oh. I guess it's the next part that I gotta look at. This is T to the 5. T5. This is T4. This is T3. Really? We could shorten this like this. Not sure if that helps at all, but maybe it does. So we got T3, T4, and T5. And then we're just going to return 6 times T5 minus 15 times T4 plus 10 times T3. So that's this. Hopefully nearly as legible too. Okay, so we got the fade part. Let's go ahead and do a gradient. Okay. Looking at this code, the gradient of one thing is that, the gradient of two things. Oh, I'm starting to remember now. Yeah, I'm starting to remember now. I'll call this like gradient vector. And I know what that is. I know what that is. The gradient vector is like which way it's pointing. So like if it's pointing up, like yeah, I think I know what this is. So like if you had a square, the gradient vectors are on each of the corners and they can be pointing away from it, from towards the center, towards the top, or towards there. And like if it's pointing away from it and this guy is pointing this way, then you have like a kind of a white slope. But if they're like pointing at each other, it's completely white. And if they're having it away, then it's like black in the middle. So that's what the gradient vector is. So in 1D, it's just up and down. So that being said, I'm starting to understand this now. So this guy, I'm just gonna take a look at this. This is very similar to just like t mod 2 equals 0. And if it is, just return t, otherwise return negative t. So getting a gradient vector. Oh, and you're getting it from some kind of random table. Is that right? Yeah, you're getting this from this like permutation table. Which, is it here? Oh yeah, look at that. I don't even know how many that is. 0, 1, 2, 3, 4, 5. Okay. Okay, I'm starting to understand. So you actually are an integer vector. We'll just call this like a random list of integers. Or you know what, that even looks like bytes maybe, but this is a random list of ints. Okay. And we'll just make this 256 integers. And every time we enable this, actually, let's do two things. And we also want a seed. So every time we enable this, I'm going to go ahead and set the seed. How do I set the seed in Unity? Unity random state seed set. Oh, init state, random.init state. There we go. And let's just set that to whatever seed we have. Okay, and then we're going to generate this list. Random list of ints dot length I++, and then we'll just say random list of ints I equals unity dot random unity engine dot random dot range. What if I just do an int dot min value, int dot max value? Okay. So that's going to give us this crazy list of ints. This is going to do that kind of jazz. I'm getting there. Alright, so we have this gradient vector. We have this random list of integers. And so that's going to give me an integer. And if it's divisible by 2, it will be one thing, otherwise it's the other thing. Right. And then finally, what's it yelling at me for? Oh, you only have, right, this is gonna be the, I don't know if that's the right, okay. That's fine. No, that's not fine. That's fine. Okay. And then we're gonna do the gradient part of this next thing, which is just the next number, and we're gonna get it from the inverse. Okay. I think that is Perlin noise. Alright, so instead of math.f.Perlin noise, let's try just Perlin noise. And let's just start entering our x divided by 100. F. And let's assume we get -1. Oh no, we're gonna get 0 to 1. Oh, but we already mapped. Okay. We got Perlin noise going. Alright, so let's go ahead and play that. So I'm hoping this and this are the same. Oh, and that's what this thing is, I guess. And I'm just making sure. We're getting random list of ints. Oh, we should check out to see what the random list of ints are. So if we go, oh, I know what would be nice too. Let's also have, all right, pixel width and height are great. I'm not using you. Ah, scale, yes, that's the one I also want. Times scale? Yeah, I think that's gonna be great. I think that's gonna be great. Okay, so we have this quad. If I made you like 0.5, yep. Okay, let's make you like 1,000. And I'm gonna stretch you out some here too, so I can see what that looks like. kind of want to just see how that looks. Maybe. I broke it somehow. Alright, so it looks like the same patterns. Okay. I guess the other thing I want to really look at is maybe scale and offset. I guess that was what was there. So let's go ahead and add that back. Public float offset equals 0. But what we can do is here we can just say plus offset. And we can kind of move that. Like 5, 10, 20, 21, back to 0, 0.5, 20, 200, 150. I feel like I'm missing something. And I'm not quite sure what it is. But I think we're in a good start. I kind of want to keep visiting this and figuring out how 1D Perlin noise works a little bit more under the hood. So I will continue my research. Not sure if I'll do it on camera or off, but we'll see. But I do want to kind of preserve my test here. So let me clean this up a little bit. I think these are fine. I'm going to delete the old code here. Okay. Got a Perlin noise function there. Fade function there, and there we go. Okay. Yeah, that all looks fine. Is it still playing? Let's stop it. Okay. Let's go ahead and save. See what we done and save it. Oh yeah, I don't really need the square material. Let's go ahead and delete that. Okay. What else? Yeah, okay. So what have we done? We added a new Perlin noise layer, and we started doing a test. So let's just say start creating Perlin noise layer and started to do a test of 1D Perlin noise to make sure I completely understand Perlin noise before moving on. Alright, which maybe I do, maybe I don't. But it is what it is. Okay, cool. I'm gonna see if my GitHub has this working. Alright, so hopefully this is my latest build before just today. Yeah, undo still seems to work. Can we do a random noise layer? Yep. And it can have random seeds. It's a refactor, so really we wouldn't be able to see much about what's happening here. So if I made you 1 and made you a random layer and made you 2, you can kind of see the difference there. Okay. I think it's all still working. That data still remained. So the new function is not really working great. But we'll optimize those things later. Open seems to be broken now. Can't undo, redo. I can erase. Okay. Stuff is happening. Oh my god, what is that even from? It's on the 3rd layer. Okay, well, okay. Cool. I'll let it be. That's what I got so far. We'll keep it going. I'll see you guys next time. Bye.